I've sent him invites all over the place, so he should have it if he's able to show up.
Oh, okay.
Group meeting quiz. All right, here we go for the quiz.
Okay. Oh shoot, I forgot to open the normal probability app. Where is it? Where is it?
Oh, there's a link in the quiz.
Oh, okay. Oh, there it is.
All right, so question 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z 1.358 and to the left of z 1.358.
Awesome.
And the combined area under the standard normal curve.
1.358. 1.358. So that's on the curve, right? So the round spot, I'm thinking.
All right.
So I'm getting 0.8255.
Hold on. Use normal probability applet to find the combined area under the standard normal curve. Standard normal curve. It's probably a standard normal random variable maybe. Between. Okay, well look at the. Are you sure it's underneath the dome? Because it's saying use the normal probability applet to find the combined area under the standard normal curve that is to the right of z and to the left of z.
Oh, never mind. We're looking for the two smaller n. Never mind.
Yeah.
Here and here. So 1.745.
Yes, that's right.
Okay. So wait, he said we should round to 3 decimal places.
Okay. Yep. So round to 3 decimal places, 0.175 is what I have for the answer.
Sweet.
Hey, Bartholomew.
Hi. Sorry, I ran in late. My network is kind of giving me some little challenges.
All right.
Okay.
So we just got done with question number 3, so you didn't miss much.
Oh, okay. I'm trying to open up. I couldn't review the notes very well. So.
Okay.
All right.
Number 4.
We got it. So we are on question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
Okay.
I'm not.
Which of the following will have a smaller standard deviation? The distribution of the individual observations. Smaller standard deviation. Distribution of the sample means. Distribution of the individual observations.
Random variation x is mean. Okay, the standard deviation of the round. Oh, got it on. I have a standard deviation. It's I think it's option 2. The distribution of sample mean. Let me see.
The sample means. Smaller deviation. Smaller 9 observations.
Because in just write the revision from last week in lesson 7. It says that the mean of a random. Oh, let me see if I can share my screen real quick. I always forget to do that part.
Okay.
But Bartholomew, I think if you turn your video off, it shouldn't consume a lot of bandwidth for your internet.
Okay,
So,
yeah.
So right here,
Yes.
this is what I was looking at when I answered. So if this is huge, this will get smaller. Can you guys see my screen?
Uh-huh. I'm looking at that. Let's see, where is it? 2, review of sampling.
No, I can't see the screen wall.
Okay, there it is. Standard deviation of the random variable. The random variable is that. Okay.
Because in a formula, I think all the x's have this little dot on top of them, and option 1 here doesn't have anything on top of it. That's another thing, because this is more of a visual aid than anything. But what do you guys think? I mean, we can keep thinking about it and come back to it, or you guys see otherwise? I don't mind.
I'm fine with that answer.
Okay.
Okay, number 5. Which of the following results implies that the spread in X decreases as the sample size increases?
Oh, I think it's right in. I see revision again. So 2, review sampling distribution. The sample size large and the center. So it says, what is the sample mean normally distributed? When is the sample normally distributed? Wait, let me see the question. No, normal. Wait, decreases. No, decrease. I thought option 3 or option 4. I'm still thinking it through.
All right. Sample means
I think it will be option 3.
The central limit?
I was gonna, yeah, I think that's right.
Okay.
Yes.
I'm still trying to understand the central limit and the lot of large numbers. It's a fine line there that I haven't gotten down, but oh, sorry. So, question 6. So I'm going to answer the next 4 questions. Scores on a quantitative portion of the area person. With me.
Deanna earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Deanna's score?
See, I'm gonna run in my model real quick. Let me see.
Okay.
She scored 60, and the mean is standard deviation is 8.8, and let's see. 1, 2, 3. One, let's go. Okay, value minus mean divided by standard deviation minus n. So I'm having a hard time finding n in this case.
N.
Yeah. Once I get n is the last input that I need. So my model can calculate it. So I got a mean, standard deviation, and the observed value, which is 160. What is n? Let's see. Oh, I guess we'll just do value minus mean divided by standard deviation in this case.
Okay.
I could be wrong, but on section 3 in a what do you call it? In a book on section 3, that's the formula that it has there. Let me see if I can share my screen real quick. Oh, dang it. There we go. So right here, let me know if you guys can see my screen.
Yeah, I see it.
Yeah, so this is what I'm using. I mean, here it still has the number here, but since they didn't give us the number, I'm thinking this part of the formula should work. I could be wrong, but that's the only thing I have so far.
Okay.
So I'll do that instead and see what happens. So equals 5, 0, 8, equal. Ooh. 1.045. Yeah, that's what I got when I did it, number 1.045.
Does he score first by the score? Okay.
But we're supposed to round up, I think. Yep, we're supposed to round up, so that means.
Yeah, we're supposed to round to 3 decimals.
Okay. Cool.
Okay, so number 7. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
Oh, there's a formula in the note for that. I didn't put that one in the system before. Okay. Whatever value is.
Student score of 160. What's the mean? 50.8. The standard deviation of 8.8.
So I get 1.045. Okay. So I put the standard the z-score we just found into the applet, or that way I can kind of let me share my screen and show you guys what.
Okay.
Okay, so this is what I'm trying to follow. Or this example did what it did. So they first got the probability that would be below that, but they just gave the number, and then what they did was they took the probability of it being below the standard normal. Wait. So they took the probability of it being below, and then they subtracted it from 1 to get the probability of it being above.
All right.
So then I come to the app, I put it in. So I do that. So this is a probability of it being below, right? Wait, is it asking for the mean?
1.045, yes.
So then the probability of it being above, if we take this out, I don't know if we need more calculation there, but I'm thinking that's what it did here. So the probability of it being below minus 1 will give us the probability of it being above.
Yeah.
Because this is the mean, right? What? A z-score.
That's a z-score.
This is z-score, not a mean.
How to calculate the z-score? I should write a formula on the z-scores.
That's why we did in steps in question number 7. So the z-score. Right here. Well.
Okay. So what do you think number 7 is then?
Number 7 was the number 6 was the z-score. Sorry. Number 7, I'm thinking it will be 0.148.
0.148. Okay.
Is Bartholomew still there?
Yeah.
Oh, okay. I think he muted his microphone. That's probably, and I'm like, cool. Question number 8.
Random sample of 5 students was selected to take the GRE. Their scores are these. As the z-scores corresponding to the sample mean of these students' scores.
Something will plug those in and get the mean, and then use the mean. Because the n will be 5. We need to get a mean, and use the mean to get a z-score.
So the mean is 160.
160. Okay.
Yeah.
Let's see.
Now I've forgotten how we calculate the z-score.
The z-score was the
value minus mean divided by standard deviation.
Yeah, and we're still using the standard deviation from earlier, right? The 8.8, right? Because it said we should use that assumption to answer the next 4 questions. The assumption from number 6.
Yes, that's right.
Okay, so that will be
GRE approximately normally distributed.
So n in this case will be 5, and you said what was the mean again?
The mean was 160.
160, 160, 0, and then the value in this case will be Do we add all these up to get a value then?
1.045. Is the z-score. Okay, well, what I did was take 160 minus 150.8 and then divided that by 8.8.
Oh,
that would give us
150. Oh, okay. Wait. 150.8. Why did you use 150.8?
Isn't 150.8 the mean?
The mean? Okay, so 150.
Well, what is that symbol mean? The U.
The U is the mean.
Okay.
Going back to the note.
So then the formula says to calculate z, you go value minus mean.
Okay, and the value in this case is what I'm having a hard time finding.
Yeah, that's what I'm wondering about.
Is it a total amount? Like if we add all these together?
That's the z-score corresponding to the sample mean. Okay, so we've got a sample mean. We were dealing with two means, a sample mean and the normally distributed mean of all the data. So we have a sample mean and all the data mean.
Okay, this.
And I think we're going to treat the sample mean as our value.
Okay.
Use that in the formula.
Okay, so I think the sample mean in this case will be all the mean of all this number, I think, because this is the sample, right?
Yeah. And I've already done that calculation. That mean is of the samples is 160.
160. Okay. Yep. And then going back to our formula. What was our formula again? Sample. Oh, wait a second. If this is approximately normal, then the sample mean is just as close to the mean, right? Isn't that what the theory says?
Say that again.
So if this is a normal distribution, wouldn't the mean be close to the sample mean? I wonder if they're just trying to trick us.
Any Android normal curve based on a sample mean. Based on a sample mean. What does the line over the x mean?
The line over the x, let me see.
Hey, Bartholomew.
That's the random variable. The mean of random is so
yes.
Remember the note, if you go to section 2, I think when the line is over the x, the mean is still, the mean of the normal population, I think. So let me share my screen. Oh, come on. This is what I'm trying to say. You see here? Can you guys see my screen?
Mm-hmm.
So it's saying that the mean of a random variable, which I'm thinking is a random sample, is u, and this is the mean to begin with. So if this is the case, then Okay, I think this is a good example.
Based on a sample mean.
So a normal population of N4 in our case would be 5 because that was the amount of student it took. The mean is 7, and our mean is 150.8 in the question. So I'm thinking so 3 over 4. 3 was the standard deviation.
The square root n would be 5.
Will be 5, and then our standard deviation will be 8.8. So we're pretty much getting the square root of 5 divided by 8.8, right?
Our mean,
because that's how we get our standard deviation, and then from there we can use it to to get. Okay, so
square root of 5.
8.8 divided by square root.
3.935.
Yeah. Yep. And then we will use the okay, we'll use that to get a z-score.
What's the z-score? So 3.935 is our z-score, right, for number 8?
That's our standard deviation. I think because that's what it did here. See, standard deviation was the mean divided by that, so that gave us 3. So now that we have our standard deviation, how do you get a z-score? Oh, wait a second. Can you see my screen?
Mm-hmm.
So right here, is this what? But then again, it didn't give. It just say what is the z-scores corresponding to the mean if these students, if what is the z-score corresponding to the sample mean of these students? Oh man, this is tripping me out.
Sample means knowledge, and then we can consider the sample. Work example, finding the area under a normal curve based on a sample mean. With a sample mean.
I guess I keep coming back to what is the observed value here. I think once we get that, it should be easy to continue from there because we did get our standard deviation, but we still need a sample mean. Not sample mean. the observed value.
Let me look over the textbook for a minute.
Okay.
So sorry, my internet is gonna give me a problem. So
right.
now, number 7.
We are on number 8, but for number 7, we've got 0.148.
Okay.
So we're on number 8 now. You know the sampling distributions. 7 standard deviation. Can you find probably the x will be greater than 10? That's 160. Whoop.
Wait a second. Okay. Let me share my screen. I think I'm getting something, but I will need you guys' help to figure this out.
Okay.
Look closely at this right here. Can you guys see my screen?
Yep.
So they give this right here, and then since the number of observation is large, which I think our observation is large, so that it shows that the sample mean will follow a normal distribution. So the z-score was automatically 20,000 here. How the heck did they get this without any calculation here? So they just took the mean over here. Oh.
Population mean the cost.
They just took this and made it a z-score.
Well, their select
this is
20,000 is just a selection, so they want to know what's the probability that the weekly cost will be less than 20,000.
Okay. Okay, never mind. I thought I was getting something here, but delete that.
Okay.
This is confusing.
Equals 15. We have 80 with 20, 15 squared. Square of the population. All right, we need to move on.
See that? Bottoms.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay. Okay, I think what we need to do is go to what's the probability of 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem. So take the mean of everything with standard deviation. Random ability should be 150.8 on average. Standard deviation 8.8. 50.8 divided by standard deviation. 8.8 square root that. I just want to like break up and study this and meet back together.
What time are you thinking?
I don't know, like 1:30.
I got 2 classes coming up, and I'm working right after that. I mean, you guys can meet, but I don't know if I'll be able to. I was thinking, I think 8 and 9 are where the stomach block is, and I still got 14 minutes left. So I was thinking we could do 10, 11, and 12 and get it done.
So question number 8, I think what I'm doing over here, I think it should probably be 2.338.
2.338.
Yes. That's my.
How'd you get it?
But when you I do the division, let me.
And you can share your screen too.
No, I was actually writing it on the sheet of paper.
Oh, okay.
Yeah, share your screen if you want.
Or you can turn on your video and show it to us.
The way my handwriting is kind of very horrible for you to.
Any ideas on number 9?
Number 9.
I don't know if this that is greater than the mean. If we put a z-score in the app, I guess that'd be 0.0097.
Okay. Enough for me.
And we're up to 10 to the 5. That's fine. Okay, suppose the mean GP. So
Okay, thank you.
Sample mean of the 81 students who are selected. Just look at the sample.
okay, that's true.
I think it would. I think number 10 would be the first one left skewed.
I agree.
Okay. Number 11. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? And I don't know how to calculate that.
That's it. I think we have distribution of sample mean. Oh my goodness.
Yeah.
Oh man. So oh my goodness. Like I can't. Okay. Sorry. I just did something silly. That's why. Zero 7.
collection of all possible sample means. X is also the population, mean of the distribution of sample means. You 70.
5.
And is the sample size. N is the sample size of 21. '81. I mean, current population. Current population. Okay, so parent population standard deviation. Parent population standard 0.7. N is the sample size. Square root of N. 9. So we go 0.7 divided by 9. 0, 7, 7, 7, 7, 7, 7.
On 0.078 or 0.077. Wait, he said round it, right?
What?
No, I was asking. Yeah, I think we're supposed to round it to just one decimal place.
Okay. I guess 0.1.
11.
Yeah, no. Yes, actually 11.
0.1.
No,
0.1.
0.1.
This one is very.
Oh, you already got a standard deviation. We already got it earlier, right? That was 0.7 divided by 9.
All right, guys, I gotta take off.
Okay.
I'm out of time, so.
Okay. Oh, sure, I got a class in 5 minutes. But Bartholomew?
Yes.
I'm gonna be taking off in like 2 minutes because I gotta get to class. But
Yeah, I think I haven't gone through the notes very well. I have to go through because since the calculations are very tough for me.
Yeah. So we'll keep studying this, and then we'll email each other if we have possible solutions. Okay.
Okay. Sounds
All right.
good.
Okay.
Okay. All right.
See ya.
Bye.
Thank you. Right.